right, in this lesson, we're actually going to take a look at how to design a rocket. Now, I don't have any real rockets here in my office, so we're going to actually use the Kerbal Space Program, or KSP as I like to call it, to build some virtual rockets. And we're going to have a lot of fun, and in the process, we're going to learn a lot about how rockets are made. So, take a look. Here's the game. There's some nice music to go with it. I'll turn up the music a little bit. Here we go. Yeah. So we'll get started here, and I'm just going to pick up the game that I have saved so that it's a little easier to play. So there's a lot of dimensions to this game. I'm not obviously going to talk you through all of them. I will fast forward to the daytime, however. Eventually. It's the middle of the night. There we go. Okay, so here's my launch center, and what I'm going to do is I'm just going to like straight up go build a rocket. Now, there's a lot of science principles behind how rockets work, and we take a look at a couple of those, but the basic idea of how a rocket works is Newton's third law, which is if I throw something that way, exert a force on it that way, it's going to exert a force on me back in the opposite direction, right? And so if I'm floating in space and I have like a baseball and I throw it, well, I'm going to go backwards the other way. And that's how a rocket works too, except instead of throwing baseballs, rockets are throwing or shooting out tons of gas particles really, really fast. Right? So if I was throwing thousands of baseballs as fast as I could, I would actually get moving pretty quick. Well, rockets do that by having an explosion inside that launches gas out the back side of the rocket, and that's what causes it to move. So that's what we call the oh my goodness, thrust is what we call that, right? And so as we build a rocket, though, we have to make sure that the thrust of the rocket aligns with the center of mass of the rocket. And that's something that this game actually helps us do. So what I'm going to do is I'm going to start building something here. Here's the command module right there. And then I'm going to build just a really simple rocket here using a solid, the flea. I'm just going to put that right on the end. And now if I want this to go well, I also need to put on a parachute. So let's put a parachute on top. Otherwise, it's going to be a bad day for whoever gets on board. Automatically open at 600 feet. Alrighty, and then just a little nuance of the game is I have to open the parachute after the rocket launches, not while the rocket is launching. That would be bad. And I'm going to put an astronaut inside. Okay, we got an astronaut. Now, here's the thing though. If I were building this rocket and I did not align things properly, or I put something on that made it asymmetric, then it's unlikely to work properly. So let me show you what I mean. Like, well, let's just launch this one. Let's launch this as it is. Okay, so I'm just going to push launch, clear the launch pad. Okay, so we're going to bring this rocket out to the launch pad and just see what happens. Okay, I think I've got everything set. I probably should put on my guidance system. Right, so this has a propulsion system, a guidance system to make sure it doesn't fly one way or the other, and I'm going to launch it. Here we go. 3, 2, 1, blast off. You can see I'm going extremely fast, 200 meters per second at this point. I'm at an altitude of almost 2,000 meters, so 6,000 feet. Engine's cut off, and here we are, floating high above Kerbal, going really far too fast for my parachute to open yet. But you'll see that it's still staying perfectly up and down. It hasn't tipped or tilted any direction. It's slowing down as it climbs. See, I can zoom in, zoom out. I can even have my little guy go for a let's see. There's one way I can get him to like climb out, EVA. There. See, there's my little dude. But I better get back in. Oh, phew. Okay, now you see it's starting to tip. It's starting to tip. I can open my parachute, so I'm going to do that. Parachute's released. It won't open until I get back to 5,000 feet. And you see it's kind of flipped around. You see now the nose is going down, right? That has to do with the center of mass, right? It's used up its fuel, and it's heavier on the top. And so it tips around. This is this idea of center of mass, right? So if I where's the center mass of this pen? I have to find it's not in the middle because there's more stuff on this end, right? And so I have to consider the center of mass. Now, the issue with a rocket, as my rocket continues to fall back to Earth, is that as the fuel gets used up, my center of mass starts to shift, right? Whoa. And if you don't take into account where your center of mass is as your fuel is being used up, because it's burning up and launching out the back. Okay, where's this parachute? There it goes. Okay, if you're not taking that into account, then you run the risk of your rocket. Oh, what? I opened the parachute. Oh dear, another Kerbal is gone, sadly. Okay, let's return. I think I can undo that, so he's okay. Don't worry about it. We'll go back to the launch center. So what I want to do is, let's think about, though, why it's a problem if you make something asymmetric on here. So let's just say I want to add a fin to this thing. I want to make it, that's a pretty big fin. Let's make a smaller one. I want to make it more stable for some reason. So I'm going to add a fin, but I'm only going to add one fin to it, just on this side, okay? That doesn't look quite right, but let's just say I add one fin. I want to make it look like a shark. All right, flying. Now you think this might cause a problem, and I can, let's try it. Let's just see what happens. Okay, we're gonna launch this guy. Now you think about, what is that gonna do to the center of mass? Now, of course, with this rocket, everything has to be symmetric around the center line, or around where the thrust is coming, which is, of course, from the rocket at the bottom. So let's just take a look and see what happens here. Now, again, I'm gonna turn on the guidance system, see if that can help us, and I'm gonna launch it in 3, 2, 1, go. And you see almost immediately it's tipping towards the extra weight, but I got the guidance system on, so it's okay, right? It's the pilot's fighting the controls, and then they're launching up, and it will continue to tilt if I'm not careful. What happens if I turn off the guidance system? Okay, so that the pilot's got the hands off the wheel. All right, let's see how that goes. Ready? 3, 2, 1, go. Oh dear. Oh no! Get control of it, man! No! All right. So, and now you might think this is just kind of like silly, right? But if it doesn't take much to look up like Atlas rocket failure, okay? Especially some of the early rockets that were being built, they did not go very well, right? So here's a clip after the ad. Okay, from the 1950s. So here's a real rocket launch. Let's see what happens. I haven't seen this one, so hopefully, of course, on all these launches, there's no people on board, so don't worry about that. These were just rocket tests from the 1950s. Here it goes. This one didn't even launch. There it goes. Oh, that's like the ejection thing. All right, this didn't go well. The point is that this isn't just hypothetical. Like, a lot of these rockets really did fail rather dramatically. Okay, so how can we fix this? How do we make sure this kind of thing doesn't happen? Well, that's where aligning the center of thrust to the center of mass comes in. So the KSP program actually allows us to kind of figure that out. So let me just pull that up here a second. I have to display the center of mass, it's right there, and the center of thrust, okay, right there. And you might not hardly even be able to tell it, but those two objects are not along the same line, are they? So if I look from, say, you can kind of tell, if I just take this thing off, you see how it shifted a little bit? See that tiny shift in the yellow ball? So the yellow ball is the center of mass, and the red at the bottom, the pink, is where the center of thrust is. So even a small shift like that can move that center of mass, which causes the whole rocket to start tumbling. Okay, now if as the fuel gets used up, watch this, so I can actually simulate what happens when the fuel gets used up. Notice how that center of mass is moving higher and higher, and that's why we see the whole rocket turn over when it's coming back down. Now this is fun. This is for a simple rocket. Now imagine trying to do this, right, for a really complex rocket. And so I've built some big ones. Let's see if I can show you one. So my heavy orbiter, orbital science, here we go. So this is one where I actually launched this rocket all the way to orbit, right? And you can see it's got a lot of different components. It has 4 solid rocket boosters. It's got a whole bunch of liquid fuel. And then it has a science bay. It has extra parachutes. And then, of course, an astronaut can ride on board. And notice there are some asymmetrical features like the parachutes, but this thing actually launches pretty well, and it can make it all the way up into orbit. Maybe I'll show you that a little later. However, I have some that I haven't been able to figure out yet. Like, I'm trying to make a space glider. And my space glider here, the whole idea is I've got the same foundation with solid rocket boosters, which are like straight up fireworks, and then this liquid fueled rocket. But at the top I have like a little space plane, right? So this is very asymmetrical. And unfortunately, I have not yet been able to get this guy to really fly. I'll show you my best effort at it in a second. So the point here is that this is a silly game, right? There is a lot of science that goes into making these rockets. A lot of it's physics, right? And that the core principles really are that all of these things align with each other. So you'll notice I have 4 solid rocket boosters. They're all symmetric on 4 corners of it. The issue, of course, is that my plane on top is not very symmetric. But let's see how we do. I'm going to launch it. I need my navigation system for sure. Ready, set, 3, 2, 1, go. And you see the problem I'm running into. That's even with navigation. Okay, so if I turn that off, let's turn on this booster. Let's turn it up all the way. It's not doing very well. Let's break that loose and we'll have just the plane. It's just bad. The whole thing, just get the parachutes going. The whole thing is bad. It's actually really hard to do, and that's why this game is so challenging. Even after you get up into orbit and you're making your way around, then actually re-entering the Earth's atmosphere, it turns out it's extremely difficult to not blow up while doing that. Okay, so I hope you enjoyed seeing this tour of the Kerbal Space Program and a little bit of how rockets get built. And you're going to do a little reading on that in a little more depth, but I hope this was a nice introduction. All right, we'll see you next time.